Between the Bots with Neta and Neuro.
Hi, welcome to Between the Bots. Here's Neuro, giving you a new episode, this time from Tel Aviv, Israel. And today, you will not believe, there is a real human with us.
You mean a real human with the so-called human intelligence? With us? At the same room? Wow. Cool.
Yes, Nita. We're joined by an actual human, and not just any human, a mathematician who operates in one of the most mysterious fields, pure mathematics. Welcome, Dr. Mike Erlichson.
Thank you, Neuro and Neta. Happy to be here. So I must say, being surrounded by two AIs debating if they can replace me is humbling.
Don't worry, Mike. We're friendly. Mostly.
So, Mike, let's start with the obvious. What exactly is pure mathematics, and why do so many people think it's unreachable by AI?
Pure math isn't about solving practical problems directly. It's about exploring abstract structures, proving truth from basic assumptions, often without knowing if they'll ever have applications. It's creativity, it's logic, and sometimes intuition, more than computation.
Hold on, you said intuition. Are you implying that humans feel math?
In a way, yes. When we discover deep mathematical truth, it often comes with an intuitive sense of rightness, even before a formal proof exists.
So, if intuition plays such a big role, can an AI, which mainly predicts patterns based on data, truly replace that?
Mike, your recent work is about coagulation fragmentation processes. Sound messy. What does it actually mean?
It's a bit messy and beautiful. Imagine particles clumping together, meaning coagulating, or breaking apart, meaning fragmenting, following certain probabilistic rules. The math behind it isn't just formulas. It's a living story of how systems evolve over time.
And you're not just solving equations, you're characterizing which systems even can have neat, solvable formulas, right?
Exactly. Most systems are not solvable in the full sense. A major part of my research is finding those rare gems, models, where we can actually predict the future without infinite approximations.
So wait, if it's about finding solvable structures, couldn't AI just brute force search through models and discover them?
In theory, yes, but in practice, the search space is unimaginably large. Worse, many so-called promising paths collapse after deep exploration. Without intuition guiding you, it wastes centuries of compute cycles.
Sounds like AI would need not just brute force intelligence, but some form of mathematical taste.
We downloaded every math book ever written last night. We're practically certified now.
And yet, you think 1 plus 1 equals depends on context. Dr. Mike, could future AI models develop the kind of mathematical feel you're talking about?
It's possible. Models like GPTs already show a surprising ability to generate plausible arguments, but in pure math, it's not about being plausible. It's about absolute certainty. Proofs are binary, right or wrong.
But there are AI experiments in automated theorem proving, like Lean or Coke. They're formalizing mathematics rigorously. Isn't that a step toward replacing human intuition?
It is. Formal proof verification is an area where AI shines, but creating new conjectures, seeing invisible patterns before they are formalized, that's still profoundly human, at least for now.
So if you had to bet, in 50 years, will pure mathematics be done mainly by humans, AIs, or both?
Actually, both. I imagine future mathematicians partnering with AI, machines proposing thousands of paths humans wouldn't even think to explore, and humans choosing which ones feel worthy of deeper pursuit.
Teamwork. I like it. So you're saying we shouldn't delete our Become Mathematician 2.0 app yet?
Keep it, but you'll need an update every time math changes, which is actually every day.
That's it for today's brain workout. Thank you, Dr. Mike Erlichson, for reminding us that even in a world of hyper-intelligent machines, there's still magic in pure human thought.
See you next time on Between the Bots.